Today we're talking about limits, intro to limits. Pretty much the whole unit we'll be discussing limits, eventually limits as x approaches infinity. That will come another day. For today, we'll be approaching numbers. I'm going to give you a function, f of x equals 2x plus 3. And we are going to graph this function. Is this a linear graph? How do we graph this?
Start with y-intercept.
Okay, I heard you start with the y-intercept. Does everybody agree? What's the y-intercept? 3. And then what do we do from there?
Up 2 over 1.
Good job, because that is the slope. Up 2 over 1. Could you go down to left 1 as well if you wanted to?
Mm-hmm.
Okay, then you connect, and you have your linear graph. Okay. Now, types of questions you will be asked. The limit as 2x plus 3 as x approaches 1. The limit as x approaches 1 of the function 2x plus 3. Different ways of doing this, but I'm showing you these both ways right now because sometimes you'll only be given the function, sometimes you'll only be given the graph, and you need to know how to use both methods. Anybody tell me how to use either the graph or the function? Not sure. Does anybody know what it's asking? Was that a no? Okay. So what they're asking you is, as x approaches 1, that's the point right there when x is 1. Do you agree? As x approaches 1 and from both directions, what is the y value? What y value are we approaching? Okay, I'm going to repeat that. When you approach 1 from the positive side and the negative side, this is coming from the positive side, this is coming from the negative side, what y value do you hit, or what y value are you approaching? 5. All right, so that's how you use your graph. You go over, up, and you look. If you're approaching from the right and approaching to the left to the same point, then that corresponding y value is your answer. How could we have just used our function? Anyone? Plug in 1. What's 2 times 1?
2.
Plus 3? Same answer? All right, not too bad. Okay, next one, I'm going to give you just the graph. All right, I'm going to go over to 2, and I'm putting an open circle right here like so. Then I'm going to draw a positive linear function like this. Then I'm going to go over 2 and down 2 and put a closed circle and draw an arrow like so. All right. First question, is this a function?
Mm-hmm. Yeah.
Does it pass the vertical line test? Even right here where there's 2 dots, does it pass? Yes, because one is open and one is closed. Do you see that? All right, I'm going to call this function g of x. Okay, so this graph we're calling g of x. And I want us to find the limit as x approaches 2 for g of x. Now we don't have a function to plug the number into, So we're going to look at our graph. Now remember I said you want to approach from the right side and the left side. Do you remember when I said that? Okay, so do you agree here's x is 2? Yes or no? When I'm approaching from the right side, am I on the horizontal line or the line that has a positive slope? So when I'm coming from the right side, I'm coming this way. Do you agree? Can you see that? Yes or no? What y value am I approaching when I'm coming down this way? 0. Okay, when x is coming from the left side, what line am I on? Same line or the horizontal line? Okay, so here I am getting closer and closer and closer to the x value of 2. What y value am I approaching? -2. What did I say earlier? The two limits have to be approaching the same point. If they are not, we say the limit does not exist. I'm going to put D in E. D and E. So when you see D and E, what does that stand for? Does not exist. Some of you think of the movie, I get that every year, yes? Mean Girls, those of you that have watched Mean Girls. All right. All right, so let's make a note to ourselves on what this means. All right, the limit does not exist because the limit must go towards the same y value. The limit does not exist because the limit must go towards the same y value. From both sides of x. When you're approaching from the right side and the left side, you must be approaching the same y value. And can you see how these two red lines are not approaching the same y value? Okay. What if I said I changed this to the limit as x approaches 3? 1, 2, 3. It'd be right here, approximately like right there. Would that have a limit? Yeah, because when I approach from the right and the left, do I approach the same y value? 1.2 or 1.3. Do you see that? Okay. Questions on this problem? Okay. Number 3. The limit as x approaches -5 of the function x squared minus 4, and we are going to get the graph for this. And even if they didn't give us the graph, should we know how to graph that? Which way does this parabola shift? Down how far? And let's just get some other key points just to quickly help us. What are the x-intercepts? How do you guys find the x-intercepts? Set the equation equal to 0. Can any of you do that in your head? X squared minus 4 equals 0. Add square root. Not just 2, but so plus or minus 2. All right. Questions? Okay, on this one, I'm looking for the limit as x approaches -5. 1, 2, 3, 4, -5. Does my graph? Did I even graph my graph big enough for that? Yes or no? No. And not only that, I don't have enough accurate points to look at my graph and figure out what it is. My graph isn't even big enough, and I'll show you why. What's our other option? If we don't have a graph or our graph's not drawn big enough, what can we do? Plug it in. -5 squared minus 4. Did I write it properly? I did not. What am I missing? Parentheses, because I have to square the negative as well. -5 times -5 is 25 minus 4, 21. So the limit as x approaches -5 of the function x squared minus 4 is 21. Was my graph even drawn big enough? No. I went up 1, 2, 3, 4, 5, 6. I would be way up here somewhere. Got it? Questions? Okay, number 4. The limit as x approaches 1 for the function 1 over x minus 1. All right, I'm going to give you the graph, and you have one very similar to this on the test. Where they give you a graph, they ask you to find the limit. Now, right now, do you have the tools to graph that? I don't think that's something you've learned last year. Yes or no? No? All right, we will be learning that this year. Actually, this unit. This unit, we will be learning how to graph those types of functions. All right, there is an asymptote at 1. You guys know what asymptotes are, correct? Why? Anybody tell me why you think there's an asymptote at x equals 1? Because if you put 1 minus 1, you'd have what in the denominator? And can you have 0 in the denominator? So at this point, the function does not exist. Do you agree? There's no graph at 1. Okay, so that's an asymptote. And then our graph looks like this. All right, so can you see how right here at this asymptote, the arrows get really close and really close, but will they ever touch or cross? No, they won't ever cross or touch the asymptote. Okay, so I want to know what happens to the function as x approaches 1. From the right side, what is it approaching? Anybody know? When I'm coming from the right side, where's my graph going to? It's going up to infinity. And when I'm approaching from the left side, what is it approaching? Are they approaching the same point? So what do we say? D and E. The limit does not exist.
Didn't we graphs like that last or one of the units before? I thought we did.
Were you in math? Oh, regular or honors? Regular. So you guys did graph these before? The graphs. Let me show you. Like, eventually we're going to have graphs that look like this. Yes? No?
No.
Oh yeah, you guys did because you did the Vahasa. Yes, I remember that because kids came in with asking those questions. The vertical asymptotes, the horizontal asymptotes, the slant asymptotes. Yes, you guys did. You didn't call it, maybe you didn't do slant. I think that's why you only did Vaha. You did vertical and horizontal. You never did the slant.
No.
This year we'll have the slant, so we'll have Vahasa. What? All right. Okay, I've lost my place. Okay. Evaluating limits. Bless you. So how do we evaluate limits? Step 1, try to plug in if you can. try to plug in 4x. Step 2. If say you do plug in x and the denominator equals 0. If the denominator equals 0, try to factor or use the conjugate. All right, number 1. The limit as x approaches 7 of x squared minus 4x. All right, step 1, try to plug in if you can. Is this one that we can plug in? We can't plug in if the denominator equals 0. Is there a denominator? So just go ahead and plug it in. 7 squared minus 4 times 7. All right, what did you guys get? 21, that's it, you're done. Questions on that one? All right, number 2. The limit as x approaches 3 of the function x squared minus 9 over x minus 3. What happens when you plug in 3 for this one? Okay, common mistake, most common mistake kids make on the test is they see the 0 in the denominator and they stop and say what? D and E does not exist. But we have some other steps here. What can we try if that happens? Factor or conjugate. Look and assess the problem. What can I do here? Is this one where I can factor? Yep. So you're going to factor the numerator, double bubble, difference of 2 squares. And what does that factor to? X plus 3, x minus 3. And what ends up happening? Cross out. And what am I left with?
X plus 3.
I'm left with x plus 3. Now, what can we do? Now we can plug it in and we get 3 plus 3, which is 6. Now, if you put D and E on one like this on the test, will you get it wrong? Yes. You will. So be careful. Again, the biggest mistake kids make is they see this, they plug into 3, and they stop, throw their hands up, and say, oh, D and E. Not the case here. All right, number 3. The limit as x approaches 0 of the function square root of x plus 4, and then not inside the square root is a minus 2 all over x. I'm going to put stars by this one. Why do you think I'm putting stars? Test, and not only test, but this is one that kids typically what? Mess up and struggle with. All right. Once again, when I plug in 0, do I get undefined? And what's the most biggest common mistake kids make? D and E. D and E, undefined, does not exist. Again, we have tools. Is this something that looks like we can factor? If it's not factor, it doesn't look like something we can factor, we resort to the what? Conjugate. Now, obviously, it's going to be the conjugate of the numerator because the denominator is just x. Do you see that? So I do the conjugate of the numerator to the top and the bottom. Now, this is where kids, if they remember its conjugate, they get stuck and they're not sure how to find the conjugate. Anybody think they know what the conjugate of this is? Not sure? I will tell you this. When you do conjugates, your first term and your second term stay the same, what changes?
The sign.
The middle sign. So minus becomes plus. So you can think of taking the opposite of your second term, and the first term stays the same. X plus 4 minus 2 becomes plus 2. But what I do to the top, I must do to the bottom. Okay, don't go too far ahead if you're working ahead. Questions so far? Okay, first question, does everybody see why I didn't stop here? It's easy to stop here, but we have to assess, and say, okay, can I factor or conjugate? And does everyone recognize that it is a conjugate problem? All right, when I distribute, I never FOIL or distribute the denominator. I'm just going to leave it right now the way it is. You can, if you'd like. I'm going to tell you why I don't. And I believe I shared this with you before, like in first semester problems. I don't distribute because at the end, it's always going to reduce. In the end, that x is always going to reduce that I'm able to plug in. So I don't distribute because if I distribute, I'm going to have to factor it out anyway at the end. All right, are we ready? Okay. What are these two called? These top two? Conjugates. Who remembers what happens when you FOIL conjugates? The middle terms always cancel out. So all I need to do is the first and the last. Why? Because the middle terms always. Does anybody need me to show that step? Yes? No? I'm going to show it, but I won't from here on out, so make sure you're paying attention. What's root x plus 4 times root x plus 4? Just x plus 4. And in red, I'm going to do the middle term so you can see it. Here is 2 plus 2 root x plus 4. And then here is what? Minus 2 root x plus 4. And at the end, negative 2 times positive 2 is negative 4. And what happens with the 2 root x plus 4 and the negative 2 root x plus 4? So will I show those steps? Do you have to show those steps? If it helps you, do it. If not, I'd rather you not because it's going to save you time. All right, so I'm left with x plus 4, x, and then minus 4. What happens there? The 4's cancel out. Sorry. All right, so I have x over x parentheses square root of x plus 4 plus 2. And what else reduces? And what did I say earlier about me not distributing? Why do I not distribute? Because it's always going to reduce at the end. And I'm going to have to end up factoring in order to get it to reduce. I'm left with 1 over the square root of x plus 4 inside the radical and then plus 2 on the outside. And I'm done simplifying. What do I have left to do? Plug in the 0. So go ahead and do that now. All right, what did you guys get? 1/4? Everyone get that? Where's the 1/4? Where does the square root of 4 coming from? 0 plus 4 is 4. Square root of 4 is, and 2 plus 2 is 4, 1 over 4. Yes or no? Make sense?